no, you guys got one more lecture after this one, chapter 10, and then there's chapter 11, 12, and 13, so I've only got 4 more lectures to prepare for this. Oh, hi, sorry, brain wandering, COVID. Yeah, still doing good on COVID. Great disease, man, love it. Where am I? Oh, chapter 9, repetition structures. So this chapter covers obviously repetition structures. This is the third type of programming techniques that was showed in. Come on, there we go. Can I get rid of this here? Bring this down here. Get that out of the screen. When we began learning MATLAB, we were doing in sequential order. The code was just executed as it was written, and then in chapter 8 we had the selection structure where you did an if statement, and if it was this condition you do this, otherwise you do that. The find, and then was newly added to the textbook was the logical indexing. So now we're venturing off into a new world of repetitive structures. This is your while loop and your for loop. Those are the 2 main structure types that we use in MATLAB. There are others in other programming. I know I took Pascal and C++. No, I didn't do C++. I just did C. There was no plus plus. That's how old I am. Plus plus wasn't out yet when I was taking programming classes, or it wasn't required. Oh, I don't know. That was so long ago. I don't remember. Anyway, I took Pascal and C, and you have your for loop, your while loop, and a do while loop. Those are the 3 that I remember. But in MATLAB, we only use the while and the for. Inside of these loops, you can create. These are our learning objectives. You can create midpoint break structures, whereas like in a while loop, that while loop will run continuously until it meets a certain condition, or you can put a midpoint break inside where if it meets another criteria, it stops the program. And you can either have it stop or skip that loop and continue on with the program. We'll cover that in a bit. You can measure time required to execute the program. I was hoping Holly would get back to me on that, because the last thing in the chapter was something that I thought would be kind of cool to play with, but I can't find it on my MATLAB. I searched my MATLAB, I searched the internet, I searched MathWorks, and it tells me to go into the apps and find the MATLAB app and go into Profiler. Well, I don't have MATLAB in my apps, so I'm not sure how to get that in. Also noticed in the textbook that they were when she wrote this book, she was using, according to the images on figure 912, where it talks about the running time, using MATLAB 2016A, and I'm using MATLAB 2021A or B, one or the other, I can't remember. So it may be that it got dropped in those 5 years. Anyway, so improve program execution time by using effective programming techniques. I mean, we're talking microseconds and save time in the program's rewrite, but like the data analysis program that my analyst writes, we could be talking minutes, hours, or maybe even days in save time by some of the techniques that you can use in MATLAB. And then we'll also, and that's part of it here, is vectorizing code. That's some of the effective programming techniques. Okay, now I spent a lot of time on that slide, and if that's what it's going to be tonight, boy, we're going to be here till midnight. So if I start dragging on, chirp up and say, hey, get on topic. Okay, on topic. The next slide, my enter button's not working, so I got to hit the go button. Hit the go button. Hit the go button. There we go. Okay, so there we go. So we had sequences, selection structure, repetitive. So this one will focus on the repetitive. But as a rule of thumb, inside of MATLAB, this is a different rule of thumb. If a section code, so if you're doing a selection code, is repeated more than 3 times, it's a good candidate for a repetitive section. So if you're doing something, if you got to do something more than 3 times, put it in a loop. But we also, you'll hear me call it loops. I mean, since I was knee-high to a grasshopper, these have always been called loops. I've never heard of this repetitive structure until 6th edition. So I will often and most likely always refer to them as a loop. A loop consists of 5 basic parts, and they are required. Some parameter be used to determine whether or not to enter the loop. If you want to force it into a while loop, you should set the parameter so that it'll go into that loop. Otherwise, it'll just skip over to the top of it. A for loop is you're nearly 99.9%. I don't know what that other 0.1% would be. It will enter the loop whether the condition is met prior to or because it runs off of an index and an array. We'll get to that in a second. So you need to have the initialization of that parameter, a way to change the parameter inside of the loop, and that one's a big one in the while loop. If you don't change the conditional statement to enter the while loop, if you don't change it within the loop, it's just that condition will always be so that it's in loop, and it's they call it an endless loop. And I'll tell you right now, it is in a textbook. What the heck happened on that page? It just mentions it a little bit on page 366. But if you get stuck in a while loop that's just running forever and ever and ever, Control C. That, as long as the control is in the command window, hit Control C and it'll stop that loop. The first time I started grading in MATLAB, some student put it into an endless loop, and I tried everything I could possibly try to get it out. I ended up having to shut the computer down and rebooting. I thought, okay, this is going to take forever if this is going to happen on all these. And then that's when Holly said, hey, just hit Control C. I said, oh, hey, cool, thanks. Again, back to the 5 basic parts. So a way to change parameter, comparison, to determine whether or not the criteria has been met. If it has been met, you exit the loop. If not, you continue with another iteration of the loop. And then you got to do some kind of calculation inside the loop. I guess it's not mandatory, but that's generally what loops are for. So types of loop, again, I already mentioned this, that MATLAB supports the loop for the for loop and while loop. With the midpoint breaks of a break will I'm going to repeat myself all night tonight because I just read this chapter, so it's all fresh in my head. So a break will stop the program, then a continue will stop the loop and continue on the code that comes after the loop. So we'll cover that here in just a minute. So how do you determine what kind of a loop do you use? Generally, if you know how many times you need to run the loop, you'll use a for loop. That is a set predetermined amount of times that the loop will execute. If you don't know how many times it's going to run, point B and one of the examples in the book, you're trying to find the sum of I don't know if it was a Taylor series or McLaren series, but you want to keep iterating that series until the difference between one integration and one element and the next element are within a certain parameter. In the book it uses 0.001. To refine it, to get it even closer to the accurate, you increase that, say like from 0.001, 0.00001, and that'll increase the accuracy. So it just, anyway, yeah. So, and then midpoint break loops are used where, like in that Taylor series, if it's not diverging to a specific value, and it's just going on forever, you could put in a midpoint break loop to say, okay, is this getting bigger, or is it reducing down to, and if it's just keeping getting bigger, you could stop the loop. Should you use a loop? Okay, so this edition of the textbook is really downplaying the importance of loops. It's more trying to push towards the logical indexing. or using the find command, because the execution time, the number of code required, it can be done quicker using the find or the logical indexing. But for us old farts that are hard to change our ways, I don't know. I'd probably still use a loop, depending on what I'm doing, I guess. I don't know. Maybe as time goes on and I get more and more comfortable with the logical indexing, I may change my ways. I don't know. So here, a good idea to avoid loops of vectorized solutions possible, because vectorized programming runs faster and usually requires fewer programs. Hey, I said that. The vectorized solution is basically your find and your logical indexing. Okay, onward. So, for loops. This is how to write a for loop. The first line in the for loop is for, and this is where one of the typos I found in the textbook is on page 343. I believe that I remember that being the page. Yes, top of page 343. So here in your loop, you start with a for and then an index. This index variable has nothing to do with the position inside of a variable. This is just a variable that indexes the iteration in your loop. And you can use that down here in your calculations, or you don't have to, but that's what it is. And then an array. An array, the way the for loop works is it looks at this array, and for every value in the array, like if this is 1, 2, 3, 4, the first time through the loop it would be 1, then the second time through the index would be 2, and then so forth until it reaches every value in that array. And then it executes these commands, and once it gets to the last value, it's done. It exits the loop and continues on with your code. Let's see what this is. The first line of the for loop identifies the loop and defines an index, which is a number that changes on each pass through the loop and is used to determine when to end the repetitions. I think I said that. Cool. So next comes a group of commands to be executed, and then finally, when it's all done, so the loop is executed once for each element in the array. So if you got 100 elements in here, it'll run 100 times unless you have a midpoint break. So here's an example, a very simple example. I think, yeah, this is going to print it out. So here we're clearing the workspace, clearing the command window, and then we got for k equals 1, 2, 3, and then it's just going to print out k and then end. So the first time through the loop, k is assigned the value of 1. So it's assigned the value of 1 on this line, and then on line 3 it prints the value to the command window, and then it does it again for the second time through, and now it's going to take the 2, and then the last time through it's going to be the 3. This is the program reaches the end of the statements. However, this time there are no remaining values of k, so it's terminated because it took the last value. Here's another simple example. We're going to take 5 and raise it to all these powers. So the first time through is 5 raised to the first power, which is 5, and then to the second power, which is 25. And then the third power, which is 125. And because we stopped at 3, that's the end of our loop. You notice here that a is a scalar, and that's because every time through the loop we reassign the value of a with the new calculation. Now there is a way, and I'm sure we'll cover that here in a minute, how to make, it's actually in the next slide, to make a an array so that it has all the calculations in there. And you also notice that k, even though it's a vector up here, it only has a single value. So if you came down here into the command window and typed k, you would just get the last value, which in this case is 3. So here is it. This is if you want to make an array out of your resultant variable. so that you're putting each of these calculated values as a separate element of the A. So the first time through here, K is equal to 1, so in the first element A, it's going to put 5 raised to the 1, which is 5. And then the second time through, K is 2, so the second element of A is 25, and then the third is 125. So this is very important for whenever you need to build an array as your output variable, because if you don't do the parentheses with an index inside, it'll just overwrite and you'll have a single value at the end, and then students wonder, well, how come I can't get a line print plot on this? Well, because you have a scalar input. So any questions on that so far? Pretty standard, simple, straightforward. Okay.
You don't mind if we use I instead of K, do you?
I don't care. I like I myself. Either I, well, you know, they don't like us using I, J, and K because they're imaginary numbers.
That makes sense.
Especially I is imaginary. Sometimes it depends on, well, in the machining world, when you're writing a program, I, J, and K are an increment from the starting point to the end point of your radius. And so I've always used I, J, and K, especially when I'm nesting for loops. Like if I want to look at each individual element in a matrix, then you'll have nested for loops, and I'll use I for one for I think I for the columns, and then J for the rows. But yeah, it doesn't matter. I'm not going to mark you wrong if you use I. Just remember that if you do use I and then need to do an imaginary number afterwards, make sure you clear the I, so it's no longer a variable.
Okay.
So creating okay, so here this same, okay, so this is the same thing, just done in LiveScript. And I think that's, yeah, okay, so we got that. Creating an array one element at a time is not usually efficient. Vectorizing the code. Okay, so here's where they're saying to do this as a vectorization using the logical indexing. You could do this all a lot faster and a lot easier to interpret. Personally, like I say, I'm just so used to seeing, although I would put an indentation here so that that's indented, but that's just me. So anyway, okay, using a for loop with an if statement. So here's a nested. So here, what we're doing in this one is we are looking at the values in score, and we're going to look at each element by element and see if any of them are greater than 90. So, and then this count is a running. We initialize count to be 0 because the first time through there should be nothing there, because we're going to take the first element and look at it and see if it's greater than 90. If it is, then it's going to increment count by 1. So now count equals 1. So we'll go through, and then the second element if it is, and then the third one, and then the fourth one. So every time that this is true, it'll increment count by 1. And so then we're going to display it. So as we can see here, that the last two are the only two that are actually greater than 90, so it returned 2. And again, they're going to say that this would be a lot easier with the logical indexing, because you could just put in scores K greater than 90. There's something along that lines. Scores equals K is greater than 90, which would return a 0, 0, 1, 1. Then you'd know that the last two were greater than 90, and the first two amint. Amint is an actual word, just people don't use it because they think it sounds funny. Okay, third pass through, and the fourth pass, they're greater, so now the program returns to line 4 because it's finished all of the stuff and there's no more to do. and then it comes down here and displays the count. Sorry, I got an itchy ear. You would think I'd edit that out before I process the video, but I'm too lazy to do that. Okay, so using a for loop with a two-dimensional array. So most of the times when you're using a for loop, it's done with a single either column or row vector. I guess it really doesn't matter. It's just easier to do a column vector. But if you send in an array that has multiple rows and columns, what it's going to do, and I don't know why you would ever do this, is it will process every row in the first column before going. It doesn't show this in the textbook, but if you had a 3 by 3, it would do all 3 rows in the code before it indexes to the next value. There's an example of this on what page? I know it's in here. I've seen it. Not while loops. Where is it? Well, it's in here somewhere. Oh, it's on page. It starts on page 344. Yeah. So cool. Okay, summary for loops guidelines. We're not done. We're only 51 slides, and we're 20 minutes. Oh, we're going to be here a while. Okay, so the loop starts for for statement, ends with the word end. The first line of the loop defines the number of times that the loop will repeat using an index and an array. The index of the for loop must be a variable. The index is the number that changes each time through the loop. Although k is often used, any variable name may be employed. Use of k is a matter of style. I have no style, so I use I. Any technique learned to define an array can be used to define the index array. One common approach is to use a colon operator. So you got your start, your increment, and your final. Okay. If the expression is a row vector, the elements used one at a time, once each time through the loop. The expression of a two-dimensional array, this means a vector column. Once you've completed a for loop, the index variable retains the last value used. I think I said that one too. And for loops can be avoided using by vectorizing the code using the logical indexing. So here's a flow chart for a for loop. It comes in, it checks to see if the index has been exceeded. So are we on the first or somewhere in between, or the very last? If we're on the in between, it goes down calculation and it keeps going until it gets to the very last one. It's done the very last one. Then it says nope, I'm done, and then it goes down and exit and continues on with the code. Now while loops. Any questions on for before we go into while?
I'm good.
Okay, so while loops are just like for loops, only different. Well, that doesn't make any sense. I know. It says right there at the top, are similar to for loops. The only difference is that it must meet some criteria in order to enter the while loop. So the big difference here is that MATLAB decides how many times to repeat the for loop. That's because based off of this criteria. So your format is while some criteria x is less than some given value, or any kind of criteria, comparative criteria. It's got to be comparative. Or if you put in while 1, then it'll automatically enter, and then hopefully you got some midpoint break inside to stop it, and then you got your code, and then an end, and then again any problem using for loop can be solved using a while loop. You just got to make sure. The biggest thing the students do in here that they skip is you've got to index the variable that's in your criteria. if you have x is less than 10 and you don't change x in here at any time, it'll always be less than 10, and it'll just keep going on and 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 on. Okay, that's enough. So the flow chart for here is identical to the for loop. It just checks to see. Only thing is it's got to check the criteria in order to enter the loop, whereas a for loop automatically enters. So here's a very simple while loop. So here we've entered, we initialized k, which is our index variable, and we set it so that we make sure that it enters the loop. If anything, if this was 3.00001, it would not enter the loop because it's not less than 3. And then we have our changing of k. So first time through k is going to be 0, so we got 1 because 0 plus 1 is 0. So again, k must be initialized before entering, and then it needs to be changed during the execution. So it's going to keep going until now k is 3. It's going to come up here and look at this and say, okay, well, K3 is not less than 3, so therefore I'm not going to do it. I'll quit. I'm done. I'm going to go get me some beer and pretzels. Yeah, so see, it says that that's not true, so it's false, so it's skipping it and going on to whatever code comes after the while loop. So here's creating an array just like we did before. This time you want to index your variable before here, because if you come down with the k equals 0, it'll enter the loop, but you'll try to assign element number 0 in a value, and that doesn't exist. You have to start your increments at 1. So we have to be at 0 to come in, or technically I guess you could be at 1 to come in because of this. But there is some homework in there that you've got to set it at this value or it doesn't work. So now it comes in, the first thing it's going to do is increment k up to 1, and then 2, and then 3, and then it'll come up here, and again it'll say that, hey, I'm 3, I'm not less than 3, so I'm going to keep going, and I'm done, and it's Miller time. Lots of traffic going up and down my stairs. Sorry, hopefully that's not distracting. Okay. So although in this instance was index number, the parentheses can often use to determine when to terminate a calculation. So yeah, we use the index, but we can do, it doesn't have to, you don't have to base the while loop off the index. You can do it, based off of, like, if you wanted these two values, this value here, oops, go back. If you wanted this value and this value, the difference between them to be a specific amount, then you could put that in your while loop. You just need to make sure that that condition exists before you try to enter that while loop, so that it will actually enter in and do good. So see here, while a is less than 10, it's going to come in, and first time through we set it at 0, so 0 is 3, then 6, then 9, then equals 12, a equals 12, but it's not going to run again because 12, when it enters the last, that loose 12, a is 12, which is greater than 10, so it stops and skips and comes down. So yeah, the criteria may not be in this guy, continue till a is less than 10. I gotta quit reading ahead of these things. And oh, hey David, I see you snuck in on us there. Welcome aboard.
Hello.
Okay, so one common use for a while loop is error checking. And this is where a while loop is really, really good and simple. If you're getting input from an idiot user like me, when you tell me to enter a positive number, the first thing I do is hit that negative sign, because I want to see what happens to your program. So if you use a while loop, you can tell it that while if it, if you're wanting positive numbers, if while x is less than 0, that's like, dude, you did put a negative number in, try again. And so this will continue to loop until I finally put in a positive number. So this is a good usage, and this is really something that I don't think you could do using logical indexing, getting proper input from the user. And then once it does finally input a valid number, then you can continue on with your code and take the log base 10 of the number. See, so here, I think Holly had me do this for her because I put in the -3, not as this, and so it'll just keep going. And personally, I if it was me after here, I would have it clear the command window again so that you don't end up with a whole string of input in here. But that's all programming format individually based. I'm not going to mark you wrong if you don't do that. Well, maybe not this week. Oh man, I'm tired. Where are we at? 21. Ooh, we only got 29 more to go. So it went through with a -3 and it didn't like it, so we put in a 5 and it finally met that condition, so it exited out and took the log base 10 of 5. Okay. Infinite loops. Okay, here's where this was taken directly out of the textbook. To press Control C at the same time, make sure that the command window is active. That means that the cursor is flashing in the command window when you execute that. If you're in the editor window, it doesn't stop it, so you got to be in the command window. Breaks and continue. The break command will terminate your program prematurely inside of a loop if that's where you have it, wherever the break command is. The continue is similar, however, instead of terminating the loop, it just skips to the next pass. So here's to do the. So in this example, have any of you tried that debugger over here yet? I think that's pretty cool. I've been playing with it quite a bit, and it's really neat. Anyways,
I have a little bit.
The debugger tool was activated by selecting line 2 and then selecting the run icon from the toolbar. So you just click over here, and then you hit the continue or the step. And if you want to step in, if it's going into a function that's not showing in it'll take you to that function, and you can step through that function. Then it'll bring you back. It's kind of cool. And it's always been there, but I've never used it before reading it in this textbook. I've always wondered why does it do that when I click that, and so now I know. So cool. And I also found how to get rid of all those little orange marks when there's no semicolon at the end of a line 2, and that is so neat. I think I need to start making the students remove that so they quit putting, because I'm still getting code come in with semicolons on everything. And then I have to go in and remove them so that I can see. Get back on point. Okay, I'm sorry. This ran until it encountered a pause at line 2. And then you just hit the step button, and then you can see the code run it one at a time. So here's your while. So it's checking to see if it's less than 4, which it is. And then repeat the step until kind of value for A. -5 is entered on line 6. Somebody entered a negative line. And so if it's line 7 is executed, the result is true, so that the commands immediately following line then includes the 2 display statements and the break. You must enter positive and the program will terminate, and it breaks. So it just stopped because you didn't enter a valid number. So when the break statement on line 10 is executed, program jumps out of the loop to the end statement on 14. So it come in here, you put in a negative number, and it stops. And then if you want to run it again, this I like the while loop better because it'll just continue to repeat until you're forced to put it in the right way. If positive value had been entered in, then it would have said, okay, that's good, so it'll skip the break and it'll come down here and execute the natural log. The continue statement is similar to break, but instead of terminate a loop, the program just continues from past the final while statement. I still got a lot to learn on this debugging stuff, but I think it's pretty cool. So any questions on break and continue? Okay.
Nope.
So let's go back here. Midpoint breaks. Problems. So in these constructs, the loop is entered, the calculation processed, and a decision made at some arbitrary point whether to exit. And then additional calculations are processed if it was good, if it didn't break and didn't leave. So the strategy could be used for a for loop or a while loop. Either loop, doesn't matter. You can use it in both of them. While one. So if you want to make sure that it enters a while loop without putting in some predetermined value, you can use a while one. This MATLAB knows that with that there it's true, so it's going to enter in here, and it will continue running forever and ever and ever and ever and ever unless you change, put in a break statement. So obviously you're comparing two values inside the loop that are being calculated, and once that criteria is met, then you can put a break statement. I guess there's probably some cases where this would be a good thing. I can't think of any right now, but then I can't think of what my name is anymore. Okay, so nested loops. Nested loops is if you're looking. So here's, they got a good example here of trying to find the maximum value in each column and then find the maximum in an entire array. So here is a matrix of numbers, and we want to find the maximum value, which, looking at it being so simple, we can see that it's 18. So we get the size of the matrix so that we know our rows and columns. So hit this first for loop for k equals 1 to columns. So this means we're going to look at each column, one column at a time. So the first time through this column, k equals 1, so it's going to come in here and it's going to say the first value of maximum is going to be x row 1 column 1. So that's going to be the first maximum value set. And then it's going to come down here into the nested for loop, and now we're using j for 1 to number rows, so it knows how many rows to look at. And then it's going to say, okay, if j were on 1, so the first column, k, first time through is going to be 1, so 1 is greater than the maximum value, then change them. And so it'll continue that for every row in here. So at the end of the first k value, our maximum is going to be 12. And then this is going to go to, k is going to index to 2, and it'll come down here, and j will be back at 1, and it'll go through all 4 rows in this case and do the same thing, and until it hits j equals 3, there's not going to be any change in the maximum because all these values are less than 12, and then at here it's going to change it because 12 is greater than 18. And then as we can see from here, obviously it's going to come up here, and k will then be 3, j will go back to 1, and look at all the rows. None of them are going to be greater than 18, so no change here, and then go back up, k is 4, and do it all, and then at the end it will output 18 because that is the maximum. Now that's probably clear as mud. Is there anything you'd like me to try and elaborate on? And actually, I did do some fibbing there. I did do some fibbing because the maximum, this is actually taking a maximum for each column. So the first column element will be the maximum of column 1, which would be 12, and then the second time through k is 2, so it's the second element. If you didn't do this, then the maximum number would be 18 at the end, but by putting the parenthesis k in here, you're creating a vector of maximum values, one for each column. So the first one will be 12, then the second will be 18, then 6, and then 13. I cry your pardon, I screwed that one up. Can we edit that out of the video? No. Okay, maybe. Okay, you guys aren't saying anything, so I'm guessing I didn't screw you up too bad. Okay, so improving the efficiency of loops, for loops, while loops, is less efficient than in MATLAB than using array operations. This clock and E time, what it does is at the beginning of your calculation, you set it to a variable. It sets the computer's clock time to that variable. You run your code, and then E time gives you the change in time between this clock and the next clock. So it tells you how long it takes to execute that code. This is really complex. There's a much simpler way. I'm not sure why we'd want to do it that way, but it does. It is still in the book. It just briefly mentioned. To look at this code here, create a vector of ones that's 1,000 characters long, and then multiply it by pi. And it took the computer that this was written on 0.003 seconds to do this code between here and here. Oops, I forget. So between lines 3 and 5, well, actually at line 4 it took 0.003 seconds to do that calculation. And there are many things. That's not just the calculation. That's the everything in your computer. I mean, if you're like me, when I'm grading, I got a movie playing in the background just for dead noise, or I got music playing, or there's all kinds of windows open. Everything that slows down your processor will be a factor in that time. And to measure the time to require the same calculation with a loop. Now, see, this one was done with the vector, using vectors in here instead of a loop. And then if we do the same thing, so here we're doing a clock before and after the for loop, we went from 0.003 to 0.098. Okay, that is a significant amount if you're a computer. To me, I mean, I guarantee I wouldn't notice a difference between the two times. But again, we're talking simple calculation here. You get into these complex programs where there's thousands of thousands of lines of code, then you're seeing a significant increase in time. So reducing the calculation time. So each time a new element was added to the B array. So that's where the time comes, is that every time through the loop it had to create a new element for B. One way to reduce that is to create B array before going into the loop, and they're going to since we have memory 1,000,000 times B first. So here, if we create B as an array, well, actually, this is not 1,000. This is 1,000 rows and 1,000 columns. So that's where that 1,000,000 came from. But by creating B as an array of ones of the same size as A, when you come in and do the loop, this is the same code as before, but we just added line 5 here, and it reduced it down from 9.8 or 0.098 to 0.017. So majority of the time was built in creating the B array for the loop. Okay, and then here's the easier way to do it rather than a clock and the E time. Just do tick-tock. Tick starts the timer, and talk ends the timer. To me, I mean, we're talking 6 characters total to get that, rather than assigning clock to a variable and then E time clock and then I don't know. Simple minds from like me, the more simpler, the more gooder.
I like it. Picasso.
Yeah. TikTok. Just don't forget TikTok. And then, okay, so here it shows that the difference in execution time expected, since the computer is doing business, it's going to be different every time, but it's going to be relatively close. Housekeeping functions. Okay, time it. This wasn't even in the textbook. Okay, so let's read this. The talk E function measures time elapsed, but code. Okay. Oh yeah. Okay. This is actually in textbook. I remember it now. So both of these return time values. It's because the computer is doing it. They do not measure time devoted just to specific programmer's execution. So if you use a time it function, it's a little more complicated to use, and I did look it up, and it is kind of a little bit more complex. You have to create a function and send it to the function, and but it just measures the amount of computer time devoted to executing the code, not the elapsed time. Yeah, see here, it needs to be stored as a function. It is in the textbook. If you want to explore that, by all means, have at it, have fun, enjoy it. Share, create a video and share it with the class. Okay, so here's their example. So there's a function here. So she basically put the whole thing that we just did in the for loop in a form of a function, and then use time it. And I mean, we're not talking, that's 0.0104, and this is 0.1046. So we're talking 0.004 seconds difference in housekeeping functions between the two. So here's how you do the time it function. I've never used it before, never even seen it until I read the textbook today. Yes, I know, I read the textbook today, but I did read it before I came online to lecture. Suppress intermediate calculations. This is one. This assignment. Because there's a part in this where you got to do a lot of this tick-tocking stuff, and yeah, this is the one where the students write the infinite loops, and it gives me grief. Just remember Control-C if you get into something that's taking forever to get through. We'll break into it and end it. So summary. Now there was one feature in the textbook that is not in this PowerPoint, and I hit Holly up for it. I think I told you guys, isn't it? And that's the run and time. It's the very last thing it discusses in this chapter. I don't know what version of MATLAB you guys have, but if any of you have something newer than the 2021 that I'm using, I'd be curious to know if you have access to it. And I can show you where I found the instructions from MathWorks to go and set that up. So anyway, okay, so MATLAB supports 2 repetitive structures, for and while, with the break and the continue. For loops are usually when you know how many times you want to do it. While loops when you're going to go until some condition exists, using the break and continue to stop it prematurely if that condition comes up. Break command community type structure midpoint. Loops should be avoided in MATLAB if the code can be formulated into vectorized format. She's pushing that a lot. Tick-tock, time it, and do not share this PowerPoint with anybody because it's copyrighted. Okay, let's see. You're in the top screen. I'll move up there. So if you're looking for the running time, it's supposed to be right up here. Mine don't have it. I don't got it. I'm in the editor, and I think I even looked in the script file. So this is a script file. It's not there. So what I found online was to go to the apps, and in here there's supposed to be a MATLAB app, and then in that MATLAB app would be a profiler, but I don't got it. I got it design, a Get S'more, install package, Adreno, Raspberry Serial, and TCP/IP. No MATLAB, so I don't know what to tell you. Wahoo. Okay, so these are the examples that are in the textbook. This is example 9.1, where it asks you to create a table from degrees to radians. I think it gives you how many, obviously because we're using a for loop. What page is 9.1 on? It's on the right page, not 8. Let's see who gets to it first, you guys or me. Right here, page 346. So it wants you to create a table that converts angles from degrees to radians from 0 to 360 in increments of 10. So that's 36. So we know how many we want to do. So we do a 4. Let's see if we can make this a little bit bigger so you guys can see it. There we go. We can use a for loop because we know how many times we want to go through. We want to go through 36 times. In order to create an array, we need to assign the output of each calculation to a new element. So degrees will be 1 times that, 10 times that, because we're going from 10 to 360. Radians is going to be the degrees variable element times pi divided by 180. So there's our for loop. That's going to create. And let's go to Live Editor. Let's put a pause right here. Pause right here. I said, and then we'll go to step, chink, and then step in. So we got degrees, radians, and it's going to go back up, and it's going to do that 36 times. I wish it was print something out. We'll point that out and see what it does to us. It might not take it. Again, I'm still learning. So degrees, radians, and there's our degrees and radians. But you got to see that was going through the loop. I wish. Well, I don't know if it's going to print out if we have it show K every time. Let's see, step down, K. Yeah, so there's K1, 10 degrees. And then K2. So it just wouldn't do it because it was already running when I made those changes. Okay, is this helpful, or am I just wasting your time here? And it's going to get down so far that we're not going to be able to see the output. So you can see that it's going through, changing K by 1 every time through the loop until it gets to the end, and then it just gets into the stuff that we learned in Chapter 7, creating a table with headers and okay. Any questions on that one? Do you want me to go through all of these?
I like you. Could you do a while loop one next?
While loop. No, I don't know how to do while loops.
Dang.
Okay. Do you want me to step it or?
Yeah, you could step it.
Okay.
I could.
We'll do what I'll get rid of all those so that we can see it go through here. And so, okay, so it's coming in. It's going to clear everything. Obviously, it doesn't clear in here, but so it's going to come down. It's going to set, okay, k is equal to 1 now. So it's looking, does k less than or equal 36? Yes, it is. So now it's going inside the loop. So the first element of degree is going to be 10 times k. And then radian is going to be that first element of degree times pi divided by 180. And now k is going to increment to 2. And then it ends and it goes back up. Is it less than 36? Yep, it still is. So it's going to continue through. I like this stepper thing. That's kind of cool. Now k is 3. Okay, and now, so here's a question. Do we have to increment by 1? No. Let's say we wanted to increment by 10. Not have so many digits. It's our program. We can do whatever we want. Well, within reason. So it's clearing everything out, setting it equal to 1. So the first time through, we're going to have k is equal to 1. Chunk, chink. So now k is equal to 11. So, whoa, that's cool. Oh, it's because we skipped the first 9 elements. So that's not so neat, but because it's got all those zeros in there between the elements. But still, I just wanted to show that you didn't have to increment by 1. If you still wanted to do this, you'd have to, I mean, there's several ways you could do it. We could set up another element in here, I equals 1, and then do an I, and an I, and an I, and then come down here and I equals I plus 1. We're going to well, yeah, we'll leave those printed. Okay. So we cleared the screen, cleared the variables. K is 1, I is 1, so k is still less than 36. So chink, chink. K is 11. Now we get I is 2. So we're going back up. And so now the second element is 110. And then third element. Maybe if I put these over to the right, it would. Not you. You. No, you. There we go. No, that don't help much either. So now we're on the k equals 31. And look at that, it's already anticipating where we're going. And it should stop. Well, it'll do this one, 31, and then it'll stop because the next one is going to be 41. Chink, chink. And it stopped because k is equal to 41 now. And it's greater than 36. And so now it's going to create the table. Header. Variable names. And there's our Did it help, or did it just confuse the bejeemies out of you by doing all that extra stuff that I did?
I think it helped just to visualize it.
And now if we run that code, it'll clean it up some. Stop. I don't want you. Go away. Well, that really hurts my feelings. So, but again, the important things on a while loop is you've got to make sure that the condition exists for it to enter the while loop, and that you change whatever the condition is. You've got to change it with inside. Because if we commented this out, and we're going to have to do a break on this because it's going to continue. Well, here let's go. If I equals let's if I is greater than, let's say, 1,000, break. Then we won't have to put a control in there. So this is going to run 1,000 times. Yeah. Yeah. Because we never changed the value of k. Did that come across the way I wanted? Was I hoping it would, or? Now, if we run that code, it'll never get there because k has changed. So here's one with a midpoint break. So what we're doing here is example 9.6, 9.3, 9.5. Midpoint break, so it's going to be in here. There it is, page 361. Write a program that calculates the value of the summation of an alternating harmonic series, assuming that we don't know that it diverges, and specify an exit from the loop if two adjacent values of the cumulative sum are less than 0.01. Also specify a maximum of 50 iterations. Okay, so this is the code, and we did this in a function. Did I say to write it in a function? I guess so, maybe. So we're passing. I guess this isn't a function. This is code. Okay, and then there's the plot. So we can change the number of iterations by making it a variable, and the criteria. We're defining y to be 1 and total to be 1. And this is important to do if this first time you use these variables are on the right side of the equation, like total here. This is the first time we see it is on the right side and the left side. So if it wasn't predefined, it would come in here and say, well, this doesn't exist. Error. Boom. Done. So keep that in mind when you're writing your loops. If you're comparing something that's changing, where this total is changing, it's got to be predefined. The y could have been okay because the first time y is encountered is here, which is based off of just negatives and our index variable. So now in our for loop, we're going to go from y equals 2. Okay. Okay, so I guess that's one reason why they did y1 up here instead of just down here, is because they skipped the index variable of y k equals 1. You could do this with a program where it started at 1, but you'd have to have another for loop or an if statement in here, because if k equals 1, you come up here to k minus 1 is 0. Well, that element number doesn't exist, so you have to start this line at k equal 2, and this one here too. So we come in here, so we've defined k equals 1, and the series shows that the first element is 1, so that's why it's set equal to 1, and the total on the first time through loop will be whatever value is in there for the first element. So we get into the for loop from 2 until maximum iterations, so the most that it will run is 50 times. So the equation is given in the textbook that y is equal to an alternating sign, plus or minus, times k. So by raising -1 first time through, with this being 2, 1 plus 2 is 3, that's a negative number, so this will be -3. When this is 3, it'll come in here, 3 plus 1 is 4, positive, which makes this a positive number. So that gives you the alternating signs back and forth. Right? Am I right? Am I right? I think I'm right. That's the way it's supposed to, but it's not looking, because 2 is supposed to be negative. I'm gonna have to, I'm gonna look at this, because I think that's wrong, but I could be wrong. Let's come up here and step through this. It could just be my coveted brain that's not seeing it right. So we're not going to see any input out of those because they're all suppressed. And we get into the max iterations. So the first time through, y2 should be a -2. It is a -2. Oh, because 2, 3, that's negative. I just said that. Oh boy, man, I tell you. Sorry, I told you it was right, and then I looked at it and no, it's wrong, because, well, that's not 2, it's 3. So now it's going to take, and the second element of total is 2, and it's going to take the first total, the first element, because 2 minus 1 is 1, and add it to the current 2, so y2, and so this is going to give us a running total. Let's stop and suppress this too. So let's step clear, go down through all these predefining stuff, 111 criteria 0.0150. Okay, so now we're into the for loop. So the first time through, y is going to be -1, -2, because it's 2, and then the total should be 1 and -1, because if you add these two together you get a -1. So we'll step it, and total is -1. So now it's going to come in here and it's going to look at total element 2, which is -1, minus total element 1, which is 2 minus 1 is 1, which is 1. So a -1 minus 1 is going to be -2, and is that less than our criteria, which is 0.00 or 0.01? No, it's not, so it's not going to break. So it's going to skip the break and go to the next value of k, which is now 3. So and it's going to be positive because 3 plus 1 is 4, positive times 3, so it's 3. And now it's going to add 3 to this, so it's going to be 2 on our total. As a running total, negative is 2. And so now, again, it's going to look at this one minus that one, absolute value, and it's just going to keep going and doing that over and over and over and over and over until the criteria of 0.001 is met. And we'll stop this because I'm not sure. I don't want to hit that 50 times. So let's suppress this output again so that we're not seeing it. Turn off that and run the section. And oh, it just ran the first section. Okay, let's run this and run in advance, run in advance, run in advance. So it did not converge. And minus 25. So it just kept getting bigger and bigger negative, more and more negative. So that's where this break, because without that break in there, it would have kept going till the max. Well, it did keep going to the maximum iterations, but if we was in a while loop, that had just kept going forever and ever and ever. And then we plot the results and we can verify that, yeah, that just keeps getting bigger and bigger and bigger. Come on, plot. I said plot. I thought I said plot. There it is. So you can see it just keeps bigger, 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 and it just keeps going bigger, 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 bigger. Oh, we lost David. Okay, any questions, comments, wants, needs, desires, concerns, complaints? Please no complaints. I'm doing the best I can.
Just a quick question. Is chapter